Morning, let's start today's session. So we're moving on to module 5 of electromagnetics. So it basically consists of two topics. As much as half portion and the second half. So we are going to moving on to the electromagnetic wave, the actual electromagnetic wave session. So before that, let's see what are the basic two types of waves. One is electromagnetic wave and the other is mechanical wave. So mechanical wave is nothing but transmission of energy in a up and down movement of particles, right? So two types of waves are there. One is mechanical wave and one is electromagnetic wave. So the comparison, just understand the comparison. So electromagnetic wave does not require any medium, it requires, whereas mechanical wave requires a medium. That means again it's transverse in nature. This is longitudinal transverse and compressional in nature. The example is light, over here the example is sound. So what is a mechanical wave? Assume that stone is fall on a water. So what happens, the wave, there will be a production of waves. So transmission of energy occurs from this point to this point in a wavy motion, right? So transmission of energy takes place from the point of action towards in a region, outer circular region. So it propagates the energy which is at this point is getting propagated to the nearby points, right, in a form of wave propagation. But actually it requires a medium since it is a mechanical wave in nature. That is example sound waves requires a medium. Vacuum, there won't be any sound, right? So let's come on to electromagnetic wave. Electromagnetic wave, light is the best example of electromagnetic wave. It moves in one particular direction, that is a transverse in nature. We will see how the concept of transverse now. We have electric field. For the production of electromagnetic wave, we have electric field and magnetic field on two right angle direction, but the wave is propagating in the third direction. That is, the particle is moving in a direction perpendicular to the uh, uh, flow of EM wave, right? So EM wave is propagating in this direction, the particle is moving in the perpendicular direction to that of the propagation. That is why it is known as transverse wave. We will deal it later. So these are the basic difference between transverse wave and electromagnetic wave and mechanical wave. Let's see electromagnetic spectrum. So our power, electric power, having a frequency of what, 50 hertz, right? So but on the contrary, see the spectrum of electromagnetic wave, the frequency, this is a frequency range. So frequency range is from 10 raised to 20 to 10 raised to 4. 10 raised to 4 means this much hertz, right? So this is a very high value. So this is the range of frequency of an electromagnetic spectrum. So actually we are producing electromagnetic wave. The concept is that you have an electron over here, so we are making it oscillate at a very high speed, not just moving in one direction which produces a magnetic field, or keeping it stationary which will produce electric field. See, we have studied that if you're having a charge like this, we have electric field around it if it is stationary, and if the stationary charge is made to move in one particular direction, we have magnetic field. Why? Because a current, if you're having a conductor like this and the current is flowing through it, means the charge is moving in the other direction, and you have magnetic field as concentric circles like this. So these are the concept of electric field and magnetic field separately. But on the contrary, we what we are doing is we will take a particle and made to oscillate in both these directions at a very high speed. So if you do that process, you can see that it will start emanating energy in the other direction, to that of electric field and magnetic field. So this is what is how we are going to produce EM wave. So there are different techniques like a spark generator, dipole antenna, etc. are there to produce electromagnetic field. It has immense applications in variety of speeds. Daily or even every minute we are dealing with electromagnetic waves. See over here, the radio waves are there, then which is of with lower frequency comparatively but higher wavelength. Then the sizes of buildings, the height of this wave, this wavelength, the height is the height of a building. Scale length is what is mentioned. Then microwave is the ranges of humans and butterflies like that. So these corresponds to microwave. We are used in cooking. Then infrared radiations, that also we know very much applications. Visible light, right? So visible light, sun's light, then ultraviolet rays, then in medical application we have x-rays, then gamma rays. See the size of this is the wavelength, the size is only the atomic nuclei, right? So the application of electromagnetic waves are extremely high in radios, mobile, TV, microwave, x-ray. Lots and lots of applications are there. So that is why this is very important. So we have studied before studying electromagnetic wave, we have studied how a electric field behave, then we studied how a magnetic field behave, then we combine the combination, and we are going to see how an electromagnetic wave is getting generated, right? See the frequency, you should be aware of the frequency range. See, this is 10 raised to 4 and this is 10 raised to 20. On the contrary, about the time wave we are studying in our electrical machines and like that is only 50 hertz, right? So this is a much higher frequency. The electromagnetic wave spectrum is having a much higher frequency and having a speed of light 3 to 10 raised to 8 meter per second. Clear? So let's see. This is the range from radio waves towards gamma waves. This is high wavelength or long wavelength to short wavelength, that or we say low frequency to high frequency. So this is again the range. So this is nothing but a static charge. So this is nothing but a static charge. If you're keeping a star stationary, you can see electric field around it, right? Only electric field around it. If you're keeping a star charge stationary, it's a positive charge plus q, and this is a negative charge minus q, that we have studied in module 2. Then we have studied magnetic field, right, in module 3, where we, instead of static charge, we started moving a charge, right? Sorry, moving in the charge in this direction. This is holes, this is electrons, I would say. So what happens if we move a charge, current will flow through circuit, and hence a magnetic field produces in a concentric fashion. This is magnetic field. So here charge is moving in one direction and we are getting a magnetic field. So we studied separately electric field and magnetic field initially. Now we're going to produce electromagnetic fields. How? This is a dipole transmitting antenna. This is a spark generator. So the spark generator is supposed to oscillate the particles at a higher speed over this gap, right? So what happens is that here the particles are made to rotate in a move in a higher speed. So electric field and magnetic field will be there associated with that particle, and that particle, if it is set to a higher speed, if it reaches its threshold value, it start generating waves, or it start transmitting energy in this direction, right? So the wave gets propagated, it will get propagated. So at a particular distance we will keep a receiver, then that receiver will get energy and it will be able to light up or receive the energy and utilize it in a proper manner. This is how electromagnetic waves are generated. All the radio waves, the mobile, the towers, everything is producing waves, electromagnetic waves, using the same concept. So moving a particle at extremely high speed will produce electromagnetic wave. Okay, so in the next portion we'll study the power which is generated from this kind of waves.